Hello everyone, myself Gitanshi Nikam. Today I will solve my second internal question paper of computer-oriented numerical math. This partial pivoting and right pivotal condensation algorithm. Now, partial pivoting is a technique used in numerical linear algebra, specifically in the context of solving system of linear equations or matrix inversions. It involves selecting the pivot element as the maximum absolute value in a certain column. Pivot element, the element used as a replace during the elimination process. Advantage, this helps to minimize numerical errors and improve the stability of numerical algorithms. And partial pivoting reduces the accumulation of rounding errors. And the algorithm of pivotal condensation is firstly we start the algorithm, and second, for each column in the argument matrix find the pivot element in the current column में pivot element search करते हैं. Then swap the current row with the row containing the pivot elements, and in the third step, for each row below the current row, a for each row below the current row. Subtract a multiple of the current row to eliminate the coefficient below the pivot and stop this algorithm. Now, question number 2 is explain refinement solution of ill-conditioned equation. A refinement solution evolves iteratively improving on approximate solution. First is initial solution, that is start with an initial approximate solution to system of equation. Second is residual calculation, calculate the residual, which is the difference between the right hand side of the equation and the product of the coefficient matrix and the current approx solution. And the third is update solution, update the current solution with the correction obtained from solving and perturbed system. And fourth is check convergence. Repeat step 2 and 4 until the solution converges to an acceptable level. Now, and in this step 6, read a point of interpolation. And in this step 7, assigns h is equals to x of 1 minus x of 0, stop length. And in this step 8, assigns v is equals to a minus x of 0 divided by h. And in this step 9, assign sum is equals to y of 0, 0 and p is equals to 1.0. And in this step 10, for j is equals to 1 to n minus 1, p is equals to p into u minus j plus 1 divided by j. Sum is equals to sum plus p into y of 0 into I and end of j. In this step 11, display a sum. And in this step 12, stop this algorithm. Question number 4 is compare iterative methods with direct methods for solving system of simultaneous equation. Now we compare these methods, iterative methods and direct methods, aspect, and this is our aspect, and the nature of iterative method is incremental requirement of solution, and direct method is computational of exact solution. And suitability, often suitable for large matrices, it is well suitable for small and medium sized matrices. Memory usage, lower memory requirement in iterative methods and can be memory intensive, and in the direct methods. And computational cost, iterative methods can be computationally efficient, time, memory, and direct methods higher computational cost. Examples हो गए iterative methods के like Jacobi, Gauss Seidel method, and direct methods के example Gaussian elimination and Gauss-Jordan. Question number 5 is write algorithm for Lagrange interpolation method. Now in this step 1 we start an algorithm, and in this step 2 read the number of data n, and in this step 3 we read data xi and yi for I is equals to 1 to n. And in this step 4, we read the value of independent variable, say xp, whose corresponding value of dependent, say yp, is to be determined. And in this step 5, we initialize yp is equals to 0. And in this step 6, we consider a loop for I is equals to 1 to 10 and set p is equals to 1 for j is equals to 1 to n. If I is not equals to j, then calculate p is equals to p into x p minus x of j and divide by x of I minus x of j. And if and next j, calculate yp is equals to yp plus p into y of I and next I. Then step 7, display value of yp as interpolation value.